Hi, everyone, and welcome. I'm here today, joined by some fellow technologists, and we're going to be talking about VMs in a cloud-native world. This is part of a series that we're going to go through where we build up the complexity, but help you understand that each stage of that journey is worthwhile taking to move you into a more agile, more cost-effective way of working as you move away from a VM-centric world. I'm joined today by David Audouin. And David is the founder and director of LiveWyer, who are a consultancy. Do you want to tell us a little bit about your consultancy, David?
Traditionally, what we do is we help companies build cloud platform capabilities. So we help companies build highly scalable, adaptable, and operationally resilient Q platforms, as well as helping them with general well-architected frameworks and well-architected infrastructure. More recently, we've been doing a lot more work with cloud-native modernization. So we've been helping companies prepare their products and their teams for moving in the direction of containerisation. And that's been a healthy part of our work in the most recent years.
And we also have Dan Banch. Now, Dan is part of Pure Storage, and Pure Storage is a company I used to work for and still work with, and an important product in the industry of containerization of state of Kubernetes is Portworx, and Dan's here to help us understand.
Yeah, so my name's Dan Banch. I'm a senior systems engineer at Pure Storage. I work with our whole portfolio, effectively our data platform, which covers simplifying storage no matter what the workload, virtual machines, physical machines, but of course, containerized workloads, Kubernetes.
So I'm Anthony Hodson. I work with Kubermatic, and we do Kubernetes in a very scalable way, which allows you to run many clusters, or fewer than many, if you prefer. And this gives you economies of scale. It gives you the ability to give each of your developers or your teams a Kubernetes cluster, which allows them to develop more freely. And what we're going to be talking about today is how all these three pieces, so the expertise, how the storage, all play in with Kubernetes itself to allow you to bring those virtual machines closer to the smarts that are going on at the end of this process, right? Where the real value is, where your customers get to use these products. And that's really what all this game of tech is about. I think we're probably all aware that there's been a lot of talk of the savings that can be made as we've seen Broadcom, who purchased VMware, up those costs, right? So they're looking to extract value from their platform, from that purchase, turn $1 into 2 or 10, whatever they think they can do. And this is, it seems to me, left a lot of the industry a little bit alienated, a little bit concerned. What we want to do is show that there's more than one reason to move away from that, more than just the cost savings, but actually the agility, the happiness of your staff who feel they have the control, the autonomy to do these things as part of a broader digital transformation journey. I like the analogy of saying, look, if you just do a lift and shift, you're taking everything from one place to another. People don't really move house that way. Yeah. I know I've moved a few times over the past years. This is an opportunity to shed things that you don't need and look to the future, an understanding of your estate, where you want to take it, and aligning with that vision, right? We can have a lovely open kitchen. We're all going to eat around the table. Right? Maybe your current table doesn't work that way. David, you've worked with a lot of customers in this journey. Are there any customers, as we look at moving from a VM-centric workload to a containerized workload that combines those aspects together, that you want to share with us today?
A classic example we've had with a client engagement is where they have looked to modernize the way that they're deploying and delivering their software stack as a service. They're using a very clear sort of tenanting model of essentially white label deploying an entire installation of their products per tenant rather than a shared model initially. So their destination is a shared tenant model, but that's quite a healthy amount of development work that's going to happen ahead. So in the interim, they're looking at more of a sort of tenant per namespace or tenant per deployment. And typically these deployments would have hundreds and maybe thousands of users for the customers. So for them, they're on a journey where they've started to build additional services, containerized services. They've been looking to pull out some of the logic from sort of centralized services and start building an independent stack. But at the core, there's still this sort of key component that maintains huge amounts of business logic that's been developed over like 20 years. So very difficult to split that out. But they've been able to go on that journey and containerize that part of the component. Where things start to fall down slightly for them within this strategy is that they have a huge long tail of add-ons, of additions, of other components that they sell and they add on. Now, for a lot of those, their deployments are relatively rare. Some of them may not have huge deployment, they're not standard deployment components, but they are critical components for critical tenants or for critical customers. And so for them, the investment of actually containerizing all of these components is a huge upfront investment for them for what could be seen as relatively little concern. In addition to that, they have a number of core components which are slightly more, let's say, traditional legacy, where it's less about the want to containerize them, but there is a huge engineering effort in being able to re-engineer and, more importantly, revalidate some of these workloads outside of their standard VM environments. And so for them, they find themselves in a position where they have a very agile sort of containerized deployment, but alongside that, they have what we call like an anchored workload based in the VM space. And that anchored workload still runs within the cloud or runs within a private data center, but it runs within VMs. And so there's all of the complications of having to have the additional networking considerations, the additional security considerations, the additional operational considerations, quite a lot of duplication of effort and time to maintain those. And so for them, it was talking to them about, okay, again, we've already identified some of these components. There's huge engineering effort that's going to take to actually move them over, but trying to provide them stepping stones and options to slowly and logically move things over so it's not an all or nothing approach. So in addition to them building containerized version of services, giving them other options outside of simply rebuilding them as container services, and giving them other options to be able to move things into that cloud native space.
What we're proposing here isn't so much that the stack is changing, but the pieces of the stack are playing different parts.
Exactly.
Because a general containerized workload will have aspects that are outside of the Kubernetes estate. They certainly touch in on systems of record. Those are typically outside of Kubernetes. Now, Dan will tell you that there's plenty of opportunity. Data on Kubernetes is a thing to bring these workloads in. And having worked at Portworx myself, major banks are running major stateful apps in Kubernetes. So I don't want anyone to leave thinking that that's not a way you can go forward. Absolutely. But typically, there's a mixing. And I'll flash up an image here of how it used to be. So your bare metal server would have your hypervisors installed on it. Perhaps there was a small amount of databases that were on these because they took up that whole estate. It was worthwhile. You had your VM-centric estate, which was very large. And this is where VMware, purchased by Broadcom, have come to sort of harvest some money, I suppose. And then you had a Kubernetes estate, which was traditionally stateless, right? Kubernetes started solving stateless problems, but it's moved on since. As we move beyond that, what we see is that the bare metal estate becomes much larger, because by removing that extra virtualization tier of Kubernetes, you see between sort of 10 and 20% more workload level. And we'll get into sort of how Kubermatic can improve that further. But you also have then the ability to run those data services in Kubernetes as well. And ultimately, you can even run your virtual machines inside Kubernetes, which allows you to then treat things as a consistent manifest. And I think that that's the most important bit of this journey, is the ability for one specification of an application to go through the whole process, and that ability to create copies that are the same, to parallel test, to spin up ephemeral environments, all of those aspects that come with agility from recreatability are playing into why this is a good idea, and not just, oh, because we can save some money. As we move into the activity of moving an application that's VM-centric into one that's more container-centric, and that might include putting some of those VMs into containers, so the proximity is there. How do we decide where to start? Because we're not going to switch something on and get this done all at once. We have to take apps through this, take workloads through this process. How would we decide where to start?
So really, we need to start with the data. Where the data is, the value of the data, the criticality of the data, that's going to inform the choices you make around whether you stay with VMs and virtualized workloads, or whether you containerize, and where that compute layer actually goes. It's good. Let the data inform that. You need to move the data. You need to get the data in the right place as well. It might need to be in a private cloud, might be into a public cloud. It could be a hybrid of the two.
Just following up on that point, from an operational point of view, one of the first things we would look at is something as simple as the data type or the access type. So is this data that's read-only, or is this data that's read-write? So what we found, again, traditionally with these engagements has been some customers want to still maintain centralized VMs for certain services if you're simply read-only. If they're just providing a read-only service, it's much more easier for them to just provide that as an API that then can be accessed from all these different ephemeral deployments. But if you're doing destructive testing, destructive interactions, you're writing data, then you want to bring that into the context of what the developer is doing or the context of the interaction. And so moving that VM, and like you said, moving that data into the context of what that developer is doing at that time, and again, from a destructive point of view, is important. And so one of the things that's held back a number of organizations on that point hasn't been the bringing the VM into that context, but actually bringing a snapshot of that data into that context.
We're working with data which is often in very large volumes. It's been historically collected, and of course you've got applications that have also been around for a while. They've been maintained on VMs. We need to ensure that we're not leaving behind those applications that may be legacy. Acknowledge the fact that they still have value. But we also talk about service classes, and often when we're working with data, we're asking organizations to identify which applications, which services collectively run together.
Looking back at my career, I stand on a booth and try to explain what DevOps was, right? And this idea of, where do you start in terms of complexity, criticality? You don't want to bet the farm on your first project, but you want to make it so that it's important enough that people get behind it. So is that where you see it as well, David? Would you start with something that's got an element of importance rather than something trivial?
I'd look at the first engagement is very much about acquiring domain knowledge, and it's finding the boundaries around your workload and understanding what the unknown unknowns are. Baked into this engagement is an element of these services or these legacy VMs. These are the sorts of VMs we're talking about, or services we're talking about, that still have that sticker on the side that says do not power down. A lot of the complications is actually less about the process of moving into the space, because that's a well-known path and there's lots of mature software and lots of mature patterns in that area now, and it's actually very much application specific. It's having people who have an understanding of the technology within the VM and how that plays within the context of a containerized workload, and what you gain, and upfront what you potentially lose in terms of certain sorts of static elements. Things now some become more potentially ephemeral. Thankfully not the data, but lots of other aspects of profile of these VMs are now slightly more ephemeral. Going back to your question, taking something as well known as possible so that the domain knowledge that you're acquiring is more around how to make use of these VMs within this new context. And then over time, start to pick more complicated workloads and complicated VMs, but the complication being the actual software that's running on it.
We've got this idea from Geoffrey Moore. So if you followed the Phoenix Project books and that sort of thing, we've got this core versus context, the things that make you special versus the things that make you present. And if we look at the application types that make us special or have the possibility of making us special, that we can iterate faster, are those the sort of things you would start with? Or is it more sort of the contextual stuff where everyone's run that workload already, we know it goes in? What would be the way that you decide that?
First of all, it's what kind of interactions the developers or the various areas in which we're going to be deploying this will be having. So will it be read-only? Will it be destructive? So looking at the data model, the access model, the IO model, and seeing what makes sense. Also looking at in terms of feedback loop. So for me, looking in terms of which services do I have the longest feedback loops in terms of change within their existing environment. So if I have if I have a deployment pipeline or a process or a validation process that takes a week for a change in this environment, within a more static environment, if I pull that in and I turn that into a 5-minute feedback, there's huge amounts of value there. So I think it's looking at, from an operational point of view, what makes sense, but then equally, if not more so, from a productivity point of view, what gets the most productivity gains from the developers.
I like that. Yeah. How do we deliver the most value so we get the backing, we get people on the boat that allows us to move forward?
Yeah.
Because it is a movement. All these things in technology are about trust and proof, and then moving forward. I mean, you could go way further than technology, right?
One of the gains from moving into a containerized space, or specifically into a Kubernetes space, is the fact that it makes you think about your workloads in a very set pattern. As you're bringing these services across, or VMs across, it forces you to start thinking about things in terms of liveness, health, metrics, and it forces you to have a definition of what working is, because Kube needs a definition of what working is for it to live within that ecosystem. So to your point, that idea of, you're not going to be able to bring everything in at once. It's this idea of systematically making those gains. I agree. And I think there is the need for, as these VMs go on this transition or this migration or this modernization effort, moving them into that space, a large part of that is you as a business validating and getting a better understanding of what it means for this service to exist or how it runs. And only then can you then move on to the next one and the next one and the next one.
I know from my time with Portworx that you have products that back up namespaces, be collected into an application, and that can be backed up. Yep. Now, Portworx backup, what does that do in the VM space? So do you have facilities to make VMs be backed up, and can those be circled up into sort of a workload?
I mean, the great thing about Portworx' role in all of this is the VMs are able to take advantage of everything Portworx is already doing for containerized workloads. And of course, we already have this expectation when we're working with persistent storage with Kubernetes, that we can treat the data, we can protect the data, we can manage it at a container-aware level, an application-aware level. We're already used to this concept that when we're doing a backup of containerized workloads, we're not backing up a whole cluster, we're not treating it as a whole lump of data. We can't work with that. It's not useful when it comes to portability or recovery. For it to be useful, it has to be granular and container aware. If we're running VMs as processes within containers, they benefit from that granularity as well. And so Portworx backup, it's giving us that granularity so we can protect VMs on a per machine basis. We can protect applications individually, and so we can treat services that are a combination of containers and VMs and treat them at a similar level of a service class. If you consider the fact that VM administrators, whether they're running on VMware or other hypervisors, they've come to expect a level of service, a level of data protection, enterprise level data management for those applications that are running on VMs. For those to be seriously considered, we need to have the same level of control. So so absolutely, Portworx backup allows us to do that.
Okay, so we're looking at the things not to do here, and that's not just what not to do when you're doing it, but also what not to do when you're thinking about doing it, right? How do you get people involved, and what do we want to avoid there? And my intuition on this is, don't think that you're going to move your hundreds of VMs out of your VMware estate in the next year, right?
Yeah.
You might have to take that hit and take that short-term agreement and use that as a reason to try hard for the next time that agreement is agreed, and move the applications at speed, but with safety.
Yes.
Rather than saying, no, we're just gonna ship everything over, because think of the risk, think of the time, and when you think of the time, think of what you're not doing.
More straightforward anti-patterns would be to fail to interrogate the workload running within the context of VM. So say that you have a large amount of VMs you're looking to move into this estate. Don't fall into the trap of just treating each VM the same and moving it in without interrogating what's actually running on it, because you may find that actually that the VM is quite easy to move over, is quite easy to containerize, then it's not an excuse not to do the work, not to put the review in, not to ask the first question is, can I do this without having to migrate this as a VM? Can I do this as moving it into a more native containerized space with an additional part of effort? So I would say, don't let that option enable you, cause you to be essentially, I say lazy probably isn't the right term, but without doing the due diligence on it. And the second, on a more straight technical point, if your VM is the size of the actual underlying instance or hardware that you're running, and you're essentially just running one VM on an instance, you might not want to do that in the context of moving it over to Kube. That seems like a slight anti-pattern.
Yeah.
When I've seen migrations from one VM into another, which often happens in cloud, the ability to move that VM holistically between one to another is fairly trivial. It is a VHD that goes in. It's the interactions between these systems that are the challenges. And getting that map of the applications, dependencies is often a lot of work for a lot of people. You can start getting that information today, right? There are toolings that will help with that. But if you don't understand how your application works, you're probably going to have to understand it better than you do today to move it.
Yes, 100%.
Yeah, it's a great opportunity to do some really thorough housekeeping. When it starts off with a discovery, I think it's a similar scenario to when an organization has an ambition to put everything in the public cloud. Actually, what actually happens is that before they even get to that point, they've got to find out what they've got. They've got to find out where the interdependencies are, and it's a similar kind of a scenario. Whether you're going to containerize things or just put them in the cloud as VMs, native VMs, there's a cost to just lifting and shifting. Even if it's technically quite easy, there's usually a cost involved, especially if it's going to public cloud. But I think there are potentially some tools or facilities that might make it easier, might swallow up some of those costs. I mean, it could be that by sharing the same platform between containers and virtual machines, actually, you've got more control as to how those costs could be absorbed. And it may allow you to accelerate bringing VMs onto the same platform, because actually it isn't such a burden. It's probably easier to do or less costly than the prospects of putting it in somewhere like a public cloud where you've got immediate costs. But being wasteful and lazy in your due diligence and discovery process actually has quite a big cost. We do come across organizations who've been a bit too hasty because it seemed like an easy thing to do.
So the way I would look at this is like, when I think about what I do for a living, I think about it in terms of I draw a lot of boxes for a living. I stand in front of a whiteboard and I draw a lot of boxes and explain what those boxes are. And when it comes to the VMs, those boxes are usually quite big, and then there's lots of smaller boxes inside. What we're doing with this operation is the same sort of thing, is that we're changing the nature of the box. Instead of talking about things in terms of, here's this VM, here is this box, it provides you this sort of capability, we start talking about it in terms of, these are the processes that are running on the box. These are the software that's running on that box within that VM. And then we start to tackle it from that perspective. And when you start thinking about it from that perspective, then, as I said earlier, the idea is that you can maybe be able to containerize more easily before you knew it. But also you start looking at it in terms of what you were saying, HA availability. Why were we running 3 of these VMs? Why were we running this much kit to begin with? We were running this much kit because we had these operational objectives. And these operational objectives were based upon us having 3 VMs because we had this recovery time, this failover time, this reaction time within our environment. Whereas once you start moving that into a containerized space or a Kubernetes space, those objectives change, those reaction times change. And so there's been many instances where we've seen, actually, I'm running 3 VMs, or I'm running this for this failover time, and I've got like pacemaker, and I've got ARP, and I've got IP addresses failing over. And so actually my service is typically down for 10 seconds while this is happening, 5-10 seconds. And then you explain, well, in the container space, if it goes down, it'll be rescheduled with the right parameters and the right configuration. We can hit and go way beyond that in terms of a recovery time. So you just have to run 1. And so now you're getting those hardware savings, you're getting better recovery objectives, but more importantly, you're doing it in a unified way. You're doing it in a way that's standardized across not just your VM workloads, or you're getting it within your all process workloads.
I really like the unified aspect of this. So going back to a diagram I flashed up earlier, all of the teams who operate today have different contexts, and their platforms have different abilities. And if you look at, I guess, sort of ruining it, I suppose, Conway's law is that you have to be able to communicate with people to change things. If people have completely different context and they're not even talking the same language, it's hard to operate in the same way. So in moving them into this, and whether they use Portworx to back up their applications, whether you're using Kubernetes Cloud Stack to run the virtualization, whether you're bringing experts in like LiveWire to help you understand that piece, all of those allow your teams to work within a similar context, and then to rely on those platforms to provide those pieces. I think what you've said there, David, about removing the complexity of having a cluster of databases when you could rely on the platform to bring up a replacement within seconds, it's really powerful, because all of those little 1% pieces that you get to make life easier add up, especially when they're consolidated and built on each other over the years. And I think really that tells us why Kubernetes has been such a prevalent game changer. And that's without even talking about the portability piece, because you'll be in a situation in future where you can just move. And today you're in a situation where you're tightly coupled to a provider. Now, it's not a cloud provider in this instance, it's a software provider. But if you choose open source, if you choose open core, then you have that ability to have a discussion with these partners from a position of strength. And you might actually find that if you have a plan, that you can get some of that strength in that discussion, right? And I think that's what we all want, is just options. Really delighted to hear everyone's understanding of the state of things. This is part of a series of 3 sessions. So we've really introduced the topic today and got into a little bit of how we think about it, how we might start to go about it. In the next one, we're going to drop down a level into some of the more hands-on practices. In this, some of the more detailed tooling to help the people who are making these decisions decide if this is the route for them. Ultimately, this will be culminating in an event that's both online and in person in mid-July 2025. But we're very open to feedback, we're very open to any questions, and we look forward to continuing this journey with you as well. Thanks.